Welcome back to our last session. We will have 3 concurrent breakout session rooms between now, right now. This first session is smart grids and digital. The second session is digital twins. The third session is cybersecurity and data management. Feel free to switch halfway through any of the breakouts. Just go back to the main event site and click on the agenda to click on the next session you'd like to. Reminder that these sessions are being recorded and will be posted after the event. The link to any session recordings can be found on the main page under session recordings. The breakout will end today at 11:30 a.m. Eastern Time, and then we will head into a break before the final closing panel. Adrian, all yours.
Thanks, Heidi. Thank you very much. My name is Adrian Kelly. Thank you all for joining. So this is the Smart Grid reverse pitch breakout session. So we talked on Monday. We got some contributions from three speakers or 3 presentations. Leonardo Petrucci from Terna in Italy, Joel Eline from PPL Resources, and myself, and well, I guess I was presenting on behalf of Antoine from RTE about the L2RPN challenge. And here we wanted to kind of now break into, that was more a lot of slides and a lot of us talking. What we wanted to do with this session was to kind of open it out and make it a bit more of a free-flowing discussion, where we have some back and forth, some collaboration, some Q&A, and some general kind of just general collaboration discussion on how both EPRI and utilities and the AI community can work together to develop solutions to the problems that we're facing with the grid. So how we define this, what we kind of want to do is to define kind of grand challenges across all of the sectors. This is just on smart grids, but as Heidi mentioned, there's things on cybersecurity, data management. Here we're focused on kind of grid operations, operations planning, those types of things. And what we as in EPRI want to do is to figure out what are the grand challenges and what are grand challenges. So we looked up the dictionary definition here, and what we mean here is difficult but very important problems which are set by institutions or professions to encourage solutions or to advocate for application funds. So it means kind of the utility or electrical engineering based entities kind of defining what the problems are and setting them as challenges for the wider industry, like the community, to solve. So on this session, you know, we've got an hour. We want to identify maybe the top 1 to 3 challenges in this area associated with kind of smart grid operations, data management, where AI machine learning could be a potential solution. That's what we want to do. We have some ideas for that, which I'll show you in a little while. So yeah, a great result of this, or great outcome of this session would be for EPRI to say, hey, we've talked to the wider industry, and here's what the collaborative think here's the collaborative think are the main challenges that AI can kind of solve. So keep that in your head, and keep that at the forefront of your mind as you're kind of talking. So I guess I try to pull out some of the themes from the call on Monday. So from both the questions we received and the presentations that we gave, I've broken them up into 5, but you know potentially there's more, and some of these cross-cut. But the 5 we've kind of looked at were around proactive decision support, visualization in real-time operations, so visualizing decision support or visualizing actions. Data management, of course, wouldn't be a session like this unless we mentioned it. One of the more interesting ones is mentioned by Leonardo from Terna about vendor procurement, or the idea of kind of going to market or developing collaborations with companies where you actually don't know what the solution is. You're not certain what the right algorithm is, whether the software exists or not. So trying to come up with non-standard collaboration methods, non-standard tenders, that type of thing. Also, like the software stack, this is something our members run into quite a bit, where you know you do a collaboration with a vendor, and then some of the software stack isn't sort of supported, or the company doesn't have maintenance support for it. So non-standard software tools being deployed. Last thing that came out a little bit was around hardware. You know, is there enough on-prem hardware server resources? You know, that eternal question of cloud, using cloud or high performance computing in the cloud. So, you know, if we abandon the cloud or don't use it, or without it, are there limits to what use cases we can develop? You know, is HPC the way forward? But where is that stored? Is it on-prem or in cloud? Those types of discussions as well that came out of a couple of the talks too. So they were the kind of five themes, I guess. The first two kind of on kind of operational challenges, and then the last three on the kind of the how, you know, the technology, or how we kind of get there. So what I might do now is, so what we're going to do is try to do this interactively, right? So we're going to try and use a interactive board like this. So I'm going to put a link to to this board in the chat. So you should be able to see it there, epri.padlet.org/AdrianKelly2 AI.EPRI Smart Grid. You should be able to click it, and when you click it, you should be able to see something like this on the screen. So I've kind of broken out, so this is a board, right? So you can add, so you're free to like write a comment underneath any of these. So hopefully you see that updating here. You're free to upvote it or downvote it, up or down vote like this. Or you're free to add your own at the bottom. If you scroll down, there's a plus sign at the bottom here. You can add in your own comment here. This is yours to work with and play with. I'll try to drive the conversation and touch off a couple of things. But feel free to kind of interact with it, and also just please unmute yourself as well. This is supposed to be an open conversation. I don't want to be talking for an hour, for sure. So I guess I might just kick off just to get things going. Anton has to leave in a bit, but I might just ask Anton for a few minutes. One of the columns here that I touched on were like the challenges or the AI algorithms. So the framework is one thing. Like presently, there's no framework that exists for like AI tools or AI algorithms within operations. Can you speak a little bit about sort of what your vision is there for with RTE and how that has developed, Anton?
Yeah, sure. So what we figured out basically is that the existing tools, for instance, the physical simulators, the study tools, etc., they didn't really fit, in the AI world as is. So we had somehow to think about some new framework where we could easily handle data, basically lots of data. We could leverage simulators yet, and we could run and reproduce experiments at a very large scale. So yeah, that's what we basically did with a framework today that is called Grid2Operate, that now the AI community is using. And so the inspiration came from the big AI guys, so DeepMind, OpenAI. They've been designing some virtual labs basically for the last previous years, where they could basically run some science at an industrial level almost. And then their development cycle from research to production is sometimes less than 2 years. So that's crazy. That's amazing. So maybe that would be a bit harder for us on a critical system to do exactly the same thing at the same pace. But yeah, so basically for us, we took some inspiration from the AI community, which is really doing some very interesting work, not only in terms of method, but in terms of frameworks, in terms of organization. How do they go so fast to almost production? So yeah, I think we have a lot to learn from them. And it's great that we have such an event this week with so many great sessions and some words from the AI community as well. So hopefully we'll get some more collaboration with them to build some commons, so data commons, code commons, framework commons, where we can all work together, on those very hard topics, but that are very essential, when we're talking about climate change, when we're talking about how electricity is running the whole digital world today. So definitely we're on a critical path there for the society, and hopefully we'll move forward. We need to move faster than we did in the past. And so,
yeah,
there's a lot to do.
So I would say as well, like RTE have developed this framework. We as in EPRI, we in EPRI are adopting that because there just isn't one out there. So we're always of the opinion, if no standard exists, get the best one available and sort of strengthen that and run with that. So the work that we're doing in AI now will sort of adopt the AI work. So hopefully by this year and into next year, that becomes the kind of adopted standard across the industry for any kind of transmission operations grid kind of AI problem. You will lean on that framework. So big thanks to the RTE guys for developing that as much as possible. Just one more before you go. I know you have 1 minute. Can you just on reinforcement learning, Antoine? There's some questions about whether that is actually the best method for operations. Can you speak a little bit about what you think on that, the way we use it in L2RPN?
So I mean, at RT, what we think is that we will not use a black box at the end. So reinforcement learning running by itself, without any interactions with an operator, is not really what we're targeting, and that's maybe the pictures that everyone gets today. So we're not targeting the autonomous grid, but yet you can learn with reinforcement learning some recommender systems, for instance, and give some recommendations through an assistant to your operators, and then it's kind of up to them to decide what looks best. But reinforcement learning has some requirements. Definitely, it needs a very advanced framework as we're developing, but it's not only useful for reinforcement learning; it can be used for many other things. And yeah, reinforcement learning. There are already some applications in the real world. For instance, Google is operating its balloons for the internet currently with reinforcement learning algorithms. Waymo is also using some reinforcement learning algorithms in their autonomous vehicles. So there are some examples that are recent, but that shows that it could somehow make a difference in the real world. But definitely there are some steps. It might not be the easiest way to make some easy steps to get some very quick value out of an application. But we think it's definitely on the midterm worth investigating and doing some investment on this kind of methods.
Yeah, I totally agree. Thanks for your comment, Antoine. I know you got to jump, but yeah. So, and even some of the innovations. So, in the L2RPN challenge that we released last year, some of the innovations year to year, months to months, are really very exciting to look at. See how they're how scientists are kind of improving algorithms over time, trying different things and seeing how they work, and then seeing the advances being made is really really nice to see. So yeah, we think it's
and China is definitely pushing a lot on this kind of approaches. So we might see some real example from China maybe in the next
yeah.
few years. So.
Definitely, yeah. Interesting note. Yeah, absolutely. So I guess so when I mentioned the grand challenge at the start, which is, again, go back to the definition. So what we want to do is find the problems to encourage solutions, define the problems which are difficult but important to try and encourage people to develop these algorithms. I've come up with 8 here, just from thinking about this over the last few years, working with the L2RPN challenge and also kind of my own research in EPRI. The 8 that we have are development of a real-time control digital assistant, which I guess Joel talked about, which from PPL, Anton and Leonardo also work on. Congestion management. So for those not familiar, this is think of a grid as kind of like a traffic network that has to be kind of managed and can't get overloaded, or else it sort of breaks down. Is there optimal ways to operate the grid or the resources on the grid to manage the congestion that flows around it? The third one is like market participant scheduling. So there's market clearing algorithms, optimization algorithms, that run on all power systems, that sort of spit out, okay, here's what the market schedule is. But now it sort of advances in algorithms and technology and computing power. Is there disruption that could be made there? Can we develop better? Can we develop faster, better, more optimal kind of scheduling algorithms? This is like very high value, of course. Then we have forecasting. This is a common one. Maybe should have been higher up the list than 4, but yeah, the forecasting of demand, renewables and weather. And I particularly say demand. I think previously when we would have said forecast, you think weather, renewable generation, but really the game changer now is going to be the ability to forecast demand, because demand is going to become so variable with electrification of society, where everybody's got solar panels for the roof, everybody has an electric car. How do we kind of predict that, stay ahead, and how that moves around? If demand is a resource on the system, can we forecast it accurately using AI machine learning? It's an important one. 5 is kind of related to congestion management. There's a lot of people that think there are a lot of flexibilities across the grid, that's underutilized. So a grid is quite static. The resources move around quite a bit, but there's a lot of thinking, research, and a lot of smart people that have been talking for a long time about, can we release some of the flexibility that's there, operate the grid in a different way, operate the resources in the market in a different way to allow sort of more flexible operations in real time. 6, probabilistic operations. So at the moment, grids, DSO grids, transmission grids, are operated very deterministically with sort of rules and criteria that date back 50, 60 years from the formation of kind of codes and standards. There's probably going to be with variable demand and variable generation, there's likely going to be a need to move to more variable operation frameworks, probabilistic operation frameworks. That might only be possible with certain AI algorithms if we can apply them. Root cause detection. This was one that Joel pulled out in his talk on PPL, where if you have an incident on the network at the same time, right now, the person sitting at the desk has to spend some minutes trying to diagnose it, looking at the weather, looking at their systems, reading, calling people, using their experience. Can take minutes, hours, could be days. And then while that happens, customers are out of don't have power. So is there tools that can be developed that will instantly flash up, hey, that was a tree, a line connecting it with a tree, or somebody drove into a pole, or a lightning strike followed by a device failure. Tells the operator in real time, kind of like the digital assistant here, what the problem was, how to fix it. 8 is system resiliency. So like I mentioned up above here on congestion management, it's very deterministic. You has to survive the loss of any single element. But resiliency looks at sort of how capable is it of surviving a shock to the system, a really massive high impact shock, like for example, in Australia yesterday, a coal generation turbine split apart and took out a coal plant that took out the network in that area. Is there evaluations that can be done to detect those kind of hidden help events to protect them from that? Again, high performance computing, AI algorithms, and then finally asset health, looking at sort of patterns in asset data and how that can be how that can show if there's something wrong with that. So I guess I've talked enough. Anybody want to come off mute there and sort of add anything here to these 9? I see somebody said, yeah, combine with number 8 for the digital assistant. Number 8 is the resiliency. Yeah, good comment. That they're very, very connected. Anyone want to jump in either from the utility side or EPRI or AI machine learning side? Feel free. No such thing as a stupid question or comment, I should say. Or anything in chat.
So let me chime in here, Andrew. This is Leon from Stanford. So,
oh, hi, Leon.
you know, I think I submitted the comments regarding combining 1 and 8. So I think we heard in the last 3 days, you know, especially the C3 AI, Steve mentions how we operationalizing the AI, basically use the AI to help the system operator make the real-time decision. Right? This is echo what you on your list of number 1, and this is really a true ground challenge, because this can be applied to anybody sitting in the control center. Could it be the transmission control center, distribution control center, nuclear power plant, or any other control centers. So this is you know, by definition of a ground challenges. If we solve this problem, this will have a broad application to other domains, right? So this is truly a ground challenge, and I want to push the envelope a little bit more. Is not just assistant system operator in normal condition, but if in some case some part of the system have failed, for instance, in your SCADA system, part of SCADA system failed, you're not able to get the telemetry into your control center, and how you can use the AI to help the system operator to make decisions. Because very experienced system operators, you know, without the telemetries in like a pre-blackout conditions, they can make a really good decision how to operate system, right? But if a relatively, you know, young system operators, they may have very tough time. You know, how can AI be able to help them? Somebody mentioned, you know, be able to transfer the knowledge from experienced system operator to the junior one. You know, this is something I think AI really can benefit and help. The second one I want to elaborate a little bit more is on the flexibility, because we heard a lot regarding the data challenge. I want to emphasize here, you know, when we go to the behind the meter or distributed energy resources, the magnitude order of the data volume we're going to receive will be different story, tremendous high. Okay, this is true in the United States with FERC Order 2222. We'll see a lot of the will participate in different level of the grid, especially in the wholesale market. And this is also true in European countries. You know, the next 10 years European transmission plan identifies that electrical vehicle and the water heater, 2 main resources to provide flexibility, right? But think about, you know, they're distributed resources. there's a millions of devices. How you handle this volume of data will be a very interesting question. It will be a very challenging question as well.
Yeah, great contribution, Liang. I really appreciate you elaborating there. Very, very good points. I will say, yeah, like I'm not sure if people were on Monday, but the whole session was opened up by a person called Neil Wilmhurst, who leads the nuclear research in EPRI. So, and his talk about from the nuclear plant, how do you kind of, if you have a guy or a girl in a station, how do you kind of assist them if they've been there for years? How do you kind of is there an assistant there that helps guide them around? And that was like completely independent of the grid. He was bringing kind of 3 Mile Island and things into it. But that was like the nuclear context. They're looking at developing digital assistants. I think the grid side of it comes out too. You mentioned knowledge transfer. That's a kind of key one. You know, can you get knowledge from senior people, store it so that it can be easily accessible later on by someone more novice if they hit a challenge. So brilliant point. On the data, totally agree as well. I have that over here. I might jump over to the data management column right here. You know, and I specifically called it out as a theme here in the middle one. So it's understanding the transmission distribution interface. I guess that goes for behind the meter as well, right? Like BTM is what we mean by behind the meter. So if you are a researcher, scientist, or a vendor on trying to apply AI machine learning to grid or smart grid applications, you might go work with a transmission utility, right? And they have a data set, you know, that associated with their grid, but that's from, you know, potentially just from 100 kV upwards. You also have like massive amounts of distribution companies that have a whole data schema as well. And then on top below that, you have, you know, home meter devices, which Liang mentioned, you know, behind the meter information from smart meters in homes, car chargers, electric heaters, that type of thing. So we need a way to be able to understand that use cases or application of certain algorithms might be dependent on the data that's available within a company or a function that you're engaging with. You know, so you might talk to a transmission company and say, oh, I'd love to solve the load forecast problems, give me all the meter data you have, and they'll say, I don't have any. Go to the transmission operator, go to the metering company, you know, go to some platform, grid supplier platform, they might have more information there. So we have to be kind of smart about knowing the kind of limits of the availability of data, and then, you know, especially now because it's going to get more and more fragmented, right? You're going to have, as Liang mentioned, some of the orders coming down where just the seas and lakes of data are just going to start flowing, but might not be clear where they're flowing, where they originate, who owns them. And then how to kind of apply technology to it. So very smart points, I think. Anybody else or want to chime in or comment? I'm trying to scan here to see did anybody add any comments, but feel free to just come off mute.
Hey, Adrian, this is Todd LeClaire here, actually, from C3 AI. And from a vendor perspective, right, without trying to push or sell anything, not trying to do that here, just want to make a quick comment based on, you know, some of the challenges that you're identifying that we see all the time with some of the utility organizations that we've worked in the past, right? You mentioned, for example, let's say an integrated utility company who wants to do some kind of generation forecast, whether that be on renewables or, you know, traditional, you know, centralized generation. You do need that data from the customer, and to connect those two, you know, can be quite the task. So where we've seen utilities really solving that problem, right? Solving that connection between the different operational silos is taking a center of excellence type approach to their data management strategy. Kind of connects back actually to the data management, cybersecurity, even the digital twin sessions as well, where I think the gentleman from TVA was talking about a data fabric, right? flowing across the organization. I understand that may not be a reality from every utility's perspective, based on organizational wise, how you're structured, where funding's coming from, but where we've seen utilities extracting the most value is really taking that centralized approach. And when you take that centralized approach, you can kind of standardize on your tagging, on your metadata management, so that when you do create that data lake, those data streams, the data oceans, and some of these utilities, right? Anyone in the organization has the ability to tap into that resource there and use it for their purposes. Now, security is obviously a concern. There may be internal firewalls you need to build up between different parts of your organization, but the technology is there to do it. It just takes the initiative, and not saying that initiative is easy by any means, but the initiative to kind of centralize and take a wider, a top level, top down view of an organization's data strategy. So, hope that helps.
Yeah, it does. Yeah. Thanks so much, Todd. I really appreciate it. I just a follow-up question. When you say center of excellence, does that mean a kind of like a team of data experts, or do you mean a center of excellence for governance of data?
So a little bit of both, actually. Typically, when so let's just take Con Ed for an example. They have an organization that they call EDAP. It's their enterprise data analytics platform. They're taking both an expert role in developing analytics and essentially being the analytic experts who are working with the subject matter experts within their different business units to come up with analytics, but they're also kind of the governing body when it comes to security, access, fidelity, consistency of the organization's data. And that's, again, not the case for every utility. Some utilities that we work might have like a consortium where you have individuals from each business unit or each section of the operating company participate in an analytics type, round table or get together once a week where they're kind of making decisions and helping to drive the strategy with how the utility will move forward with their data-driven initiatives.
Got it. Yeah. I think like the data governance, I think, is huge. Like I think all utilities will have to, both for cybersecurity reasons, but also I think everybody talks about, applying AI and all that, but without good governance standards, those types of data councils or things that set security and set access, all of that, you're really just fighting against an upstream tide, or fighting against a tide. So the data piece goes hands in hand for sure with the algorithms piece. But really good contribution, Todd. I really appreciate you coming on and joining there. I've taken some comments there. Anybody else, anything to kind of add here in general before we dig in a little bit more?
Hey, Adrian, this is Jeremy. I just thought I'd say really quick that I love this board that you have, and I'd really encourage people to kind of jump on and start using it more, add some comments, add some ideas, upvote, downvote. I think it's a great way to not have to jump on and say anything if you don't want to, but really make sure that your voice is heard.
Yeah, thanks, Jeremy. Yeah, cheers. Yeah, we like the Reddit upvoting here, especially for the challenge part. We might take this. We've only got a couple of votes in, but we might take actions against some of these that have good upvotes or downvotes. So feel free to cast your opinion or cast your vote here on where we should be kind of focusing attention. So yeah, thanks for that, Jeremy. It's open, should be open to anybody to add some comments on and all of that. So I might jump over to some of these themes. So I've numbered the themes from earlier discussion. So proactive decision support. This is identified by Joel and Antoine. Also, identifying what the grid issues are using forecasts, but also sort of something kind of sitting in parallel that's working in simulation on a simulator in parallel, and looking at sort of issues on the system. Now we did say congestion, but there's other kind of issues like around voltage or stability of the system, or kind of how reliable it is from a contingency standpoint, or how resilient it is. This concept of getting kind of actionable information out there to an operator. So human operator oversees it, of course, and then you have a kind of autopilot that's assessing the grid parameters and presenting results to the operator. Some of that is, you could call it a digital assistant. It can be like a site simulator, automatic simulator, whatever it can be. But then this concept of trust, this came up in the Q&A on Monday's call. How do we get trust? How do we build trust in these? I'd be interested if anybody has opinions on this that they'd like to share. That a lot of companies have, and researchers, and even us in EPRI have some ideas for AI algorithms that will spit out a result and say, hey, you're going to have a problem in 3 hours time that you're going to need to adjust the system for. How does the cynical 40-year veteran engineer that's seen it all before, how do they then come along and say, oh yeah, that's correct, I'm going to do what that bot has suggested that I do? How do we build that trust in technology and tools? Anybody want to contribute there? Any ideas or experience on it? No. Yeah, one of the things we looked at, I'll just give my own perspective.
Let me chime in here, Andre. So this is Leon. I don't think trust is an issue, and it's really about the nature of the work for utility folks, and also for the folks that is specifically managing the system operator, right? Because system, if you're in control center and you have a guidebook you have to follow, and you have to not compliant of all the operation criteria for system operators, and this is a very rigorous work. You have to follow the guidebook, and it's really about how the AI can assist them to, AI provide extra value, but they have to comply with the NERC standards. This is how you kind of do the impedance mismatch with what the AI is going to tell you, what is the guidebook is already there. Right? And a genius way is really you can build the operational guidebook into the AI algorithm. Then you can help to bridge what the compliance ask you have to do versus what is the technology tell you can perform the task better. That's one. Second is trust AI is the same thing as trust model, because all the existing past 50 years or 40 years is what we operate and plan the system is based on model and based on simulation. It's a model-based approach. Right. And AI is a data-based approach, which is relatively new in the last 20 years. And how you combine the nature of these two type of work, model-based approach with data-based approach, and it's different terminology. Somebody call it hybrid approach, somebody call it cognitive simulation. But the key is we already trust the model based on our existing work, and whatever is transmission planning, distribution planning, transmission operation, and distribution operation. And the next step is you combine the AI into your planning and operation framework. I'll stop here.
Yeah, that's a nice way to think about it. Yeah, really good way to think about it. I like that. I like that approach on model-based versus data-based. Question becomes is how does the model-based approach break more fragmented? Does the model-based approach more fragmented, right? That does them become weaker, decentralized models? You might have had a model of a large nuclear model come to good and up to speed, but then right away and they're replaced thousands smaller. This is right there. I guess the question is the model that we're speed. The question is more, is that the question? A rhetorical question is, is the move to decarbonized future of forcing a move to new techniques for analysis for future techniques for analysis. Good comment though. I like that idea of making sure that the NERC standards are sort of built in, standards are sort of into, so, you know, for any vendors that are there, you know, we on the decision making process, the decision we have the NERC process, we have NERC standards there, N-1, N voltage or voltage should be. Their sort of call in terms of building to this. So I like that comment too. Thanks. I also want to jump in there. Any vendors or researchers got opinions on their trust people on what the decision is that we have the standard there. We can move on. The other kind of areas we did touch on as well. We might not spend too much time there. The visualization part, you know, how to the visualization of these, you know, tools for planning. If you're studying huge quantities of information, we saw you have so charts for operations. I think they're only now become.
Adrian, I need to interrupt.
Here.
But we're having a hard time hearing you. I'm not sure if I'm the only one.
Is that better? Can you hear me now? Okay, Jeremy, thanks.
Adrian, I can hear you much better.
Apologies for
I think that's
that.
better, yes, sir. Thank you.
Yeah, my VPN and video combination, not ideal. So yeah, what I was I think I was saying before I was disconnected was this concept of, you know, how do we get insights from, you know, clustering. So Leonardo presented a good graphic of, you know, where the clustered data points. I might just bring it up here if I can find it. Yeah, you see here, like, you know, coding clusters, like these might not be useful. You know, the algorithm might be great. The data input might be fine. As per Todd's point, you might have really good governance. You might have a exceptionally well-designed network, neural network, and really good algorithm. But then, if the output is something like this, either for a real-time operator or somebody studying a planning data set, if the output's this, you know, how do we get insights from these charts, these trends, these data viz? Like, can we improve on data viz coming out of this to say, okay, I've got these clusters, but what this means is that, you know, these points are telling me that your system is under threat in these scenarios. You know, using kind of big data not just to create these charts, but also get actionable decisions or trigger points kind of out of them. So think of this in a large video wall in a control center. You know, we don't necessarily want this. We want a one-liner to say, you're going to be in trouble at 6 p.m. today because your forecast is off, or your load is off, or your stability is off, or whatever it is. So anybody thoughts on data viz more generally, how we can get kind of actionable info out of that, kind of targeted at specific areas of the network in particular, not just, hey, you're going to be in trouble at 6 p.m. It's saying, hey, you're going to be in trouble at 6 p.m. Your problem is in 3 Mile Island Station, and you need to reduce its output by 200 megawatts to fix that problem. You know, that's the dream for real-time operations. Anyone inside or want to come on and talk to that? Pretty quiet crowd. Is the focus kind of on developing their algorithms or straightening out the data, tagging the data, or do you think that Viz is sort of already solved as an issue? A lot of shy folks here. Feel free to put a comment in. I can come to the comment if I see them on the screen. I'll read it out loud and address it. But yeah, if you've got something to say, feel free to do so. I don't want to belabor the point, but yeah, jump on if you got something. The other kind of last two elements, and conscious we've just got 10 minutes or so left, but this concept of, which came up a bit on Monday, how do we define good collaborations, you know, with the industry, between utilities and the industry? One of the things Leonardo said, you know, was how do you go to market when you don't know what the solution is? You know, how do you design a tender, or how do you ask the industry to solve a problem when you have no clue what the algorithm might be, what the software used might be? You know, so finding a way to come up with non-standard tenders. We've seen that collaborations, you know, challenges, setting competitions and challenges like with funding inducements, like L2RPN, we've seen that to be very progressive, and has got some good results. But is there a sort of any thinking here from the vendor side of it, on how that can be improved, or is there ways that this can kind of speed up without rigidly sticking to procurement rules and tenders that like are very difficult to fulfill if you've got technology that doesn't quite exist yet? What's there? Nothing else. I'm getting my throat cleared anyway from talking. But yeah, maybe that's probably a bit boring, but the driest topic to talk about. But yeah, I think it is kind of important because, you know, a lot of the utilities we deal with are regulated entities. They've got like certain budgets to spend. The regulators oversee their budgets, and they're subject to like state or country procurement rules. You know, and then the vendors that they collaborate with have to be, you know, obviously experienced and compliant and all of that. So very rigid rules around that. But you know, if we want to push that boundary and push that envelope to work with the best people, the best companies, and let people at it with large data sets, perhaps we need to think a little bit differently on how we kind of set up these types of collaborations, you know, and give a bit of space for companies to work within, rather than being kind of very prescriptive about what needs to be done. Obviously, you do want a solution at the end of it, but sometimes these are kind of more difficult to achieve, these types of experimental projects. And then the other point on this stack here was about the software stack, that, you know, when utilities come in. This is another really good slide by Leonardo. I hope he doesn't mind me using this, but yeah, here he mentioned that, you know, some of these technologies, they're in Docker containers across all of the layers. You know, that the company, the utility company, in this case Terna, you know, they don't have these applications in house, and they don't have support for them. They don't have maintenance of them. But you know, they needed providers, the vendors that are working at these are really comfortable working with Docker and a whole different stack that traditional utility companies might never use or never come across. So this ability to be comfortable with software technology and tools that are there, I think utilities traditionally are a little bit scared of this for good reasons, cybersecurity, resilience, all of that. But this is something that we need to think about a lot more, I think, when defining these challenges. Yeah, just having kind of having freedom to deploy good technology, the latest and greatest technology and tools, without being bound by being unnecessarily bound, I guess. So yeah, that definitely came out of Leonardo's talk, and I think we're seeing it as well with EPRI, where we're working with our members to get software deployed, and it's becoming difficult even with Docker. It's becoming very difficult to do that because of the kind of restrictions that are there. Any comments there? Feel free to add them. Let's do a refresh. Lastly, I think we've got 7 minutes, but lastly was just on the hardware aspects. You know, one of the things that there's a kind of ever constant debate about utilities and the need to kind of have infrastructure that's able to be moved to cloud versus on-prem to take advantage of, you know, high performance computing and different things like that, because on-prem computing might not be sufficient for what the applications are trying to do. So the question kind of is, you know, without cloud, you know, are there limits to the use cases, right? Like if cloud is a no-no from the get-go, then does that limit the set of use cases we can do? You know, is it possible to develop these types of tools or systems without cloud or HPC? For example, in the L2RPN project that we ran last year, the winning entrant was able to train their agent on a 5,000 core machine. That wouldn't exist. That wouldn't exist in many locations. Never mind in utility companies, but it's kind of doable sort of with you know, cloud infrastructure if the right investment is there. So does this set a limit on what we can do, on an upper limit on our ambitions? And then kind of can we use that then to sort of change the conversation with utilities, with standards makers, with regulators, where that goes? Likewise with, you know, high performance computing, if that needs to be on-prem, then the costs with that, and if a new tool needs to be deployed, you know, the servers that are needed, all of that, the hardware side of it. I think it sometimes gets overlooked, but it's worth calling out here. It was mentioned on Monday as an issue. So anyone want to contribute there? This is, I think it was maybe less of a breakout discussion, more of a one-way discussion. But hopefully, feel free to add. We'll keep this Padlet board open. So this will be open ad infinitum. We might add it to the email list afterwards, and send it around for people to join. If you want to send it to people that kind of within your organizations that might find it interesting, feel free to do so as well. You can kind of add your comments to it. Like I said before, upvote, downvote, different things. So feel free to do that. We especially on the grand challenges. I might circle back to that for the last couple of minutes here. You know, if there's any others that people would like to add, then, you know, feel free to do that and let us know as well. There could be something here that we're missing following kind of a brief consultation with it. Definitely this is where the focus kind of needs to be with us here. These other aspects are kind of themes that we brought out of the conversation. So Last call. I don't want to keep people too late or late beyond the time frame. Last call for comments. Annie, was this session useful? You know, is it something we could consider doing again with a bigger audience, with more guest speakers? Anything people want to add here on the session itself? Oh, very good. Well, I guess I'll if there's no more comments and no more comments on the board. I'd like to thank the contributors, Liang and Todd and Jeremy and folks that came on to talk. Anton earlier in the call. Like to hopefully you got something out of this session. We'll leave like I said, we'll leave the Padlet board open. Feel free to join, and I'd like to thank you for your participation in this EPRI reverse pitch week of presentations. Always open to suggestions and comments. I'd also like to, while I'm here, I'm going to draw your attention to the L2RPN website. So epri.com /L2RPN is where we have all the information associated with the Learning to Run a Power Network challenge, including kind of defining how it works, the link to the competition page, the GitHub, videos, a white paper, lots of information there as well. So that's like a shout out for the work that Anton and I are doing and have done and are doing this year. So yeah, feel free to join there if you've got any comments or questions. Kelly@epri.com or through the AI.EPRI portal. Put some queries in there and we'll get them directed to me. But if there's nothing else, I'll close the event, and thank you for your participation, and let's talk soon. Have a great day.